Hello guys, my name is Vishal Jaiswal. I've analyzed this Titanic dataset. I'll be presenting my showing you my analysis. My conclusion in this dataset is that female passengers had more chances of survival. Chances of a female passenger to survive was 74%, and passenger people who were traveling in class 3 had 24% survival. And the third point is that uh, people who were traveling medium size family 56% chances of survival when compared to people who were traveling with large or seven, five. Okay. Or also people with medium family size has more chances of survival than people traveling, and people were between the age of have had less chances of survival. And there are various reasons along these lines. I'll be showing you also because people were trying to save kids and female. They are saved first in any kind of accident, even or calamity or any unfortunate incidents. So that's why, and people are most and ones has more strength, ability to save others. Those are the few points to consider when we are looking on these. The heat map which I have created, and it does show that male passengers had very less chances of survival. Correlation between male and survival is very. However, correlation between medium size family survival is good. 0.25 is considered good on this, right, and fair. It, the, the survival also has good correlation because these are the people who were traveling in class. They had more chances of survival. Yeah. And in class 3 has a negative correlation. So it shows that people travel but traveling in passenger class lesser chance. So you all these things where I am drawing from. Okay. Also access this complete analysis in the link given in this this will have a link. So these here I have quoted the necessary language. I have data to begin with. I have started with analysis with taking an info set where I can see data has 891 rows and 12 columns. 891 rows and 12 columns. And first itself it is showing me that cabin has only 204 observations. There is 740 observations. Embarked has 889 observations. That means there are few values. Also, I can see that their ID is integer format, like object, it or female. Passenger class int. Passenger class is defined as 1 to. That's why I have this. I'm trying to visualize visualize percentage of, so here, this is total value. The observation should be at 91 where there are no passenger ID, Y, passenger class, name, sex. But however, age has 177 values, which is close to 20%. 607, which is close to 77%. The data is missing. Okay, and embarked. Embarked has only two missing observations. Good, no problem. So we can say that cabin will not be of any use because it has more than 50% of missing. It will be a wise option to drop this. That's why it has been dropped here itself. And now showing you the bar chart and the values. So here age has less number of observations. Embarked has only two missing. You can visualize that here also. Then we are moving on to looking into how many male and how many female observations are missing in for females observation. For males we have 124 missing. So I don't see any relationship between the missing values and the gender. So this looks like bit random because male has 124. That no, it is not related. Then I am filling the values column with mean of the, because while analyzing I saw that age is distributed very normally. I can say it's normal distribution, does not have any, does not have any miss and all. So we can mean is the better option. And embarked I have replaced with mode. What is mode? Mode is the most frequent object, most frequent observation. S or whatever is the Titanic was going to Southampton. I'm naming it correct. It is Southampton, something like that. S represents that. It represents the city which Titanic was going. So S had more number of occurrences. The mode was S. So it uh, missing values in column has been replaced by S. Then I'm again showing you that we have filled all the missing values. Only two columns. Is and embarked has those. Given we have dropped already. There are no more. During this chart, our chart. Now we are trying to see people who survive. How many people did survive? So out of 891 observation, 891 people, 549 not survive. Only 3% of the people survived, could not survive. That the uh, death was death rate was, here I am. Here I have taken out the segregation of people traveling in class, like in passenger class 3, 491 people were traveling. Passenger class 2, 184 people were traveling. In first class, were traveling 106. Again, I have tried in that for people 24.24% traveling in class. Only 105 in out of 230. only 100, 206, only 136 people could survive. And out of 184 people in class was 20.65% of the total people traveling. 57 people could survive in the same way. 491 people, just 55% of the total population. So they're in third class. Class 3, 49, 55% of the players were traveling in third class. Out of 491, 100 very less. So most number of people died in third class. So highest number of people died, 372 died in third class, followed by 97 people died in second class, people died in first. The numbers are very high. From here only we can say that people traveling in third class, people traveling in passenger class 3. Sorry if third class sounds wrong. Passenger class 3, people traveling in passenger class 3, very less chances of survival. Same representing the same with the 370 to survive passenger class 3. Here we are trying to visualize a number of people traveling alone versus if they were traveling with their parent or their child or their sibling or their spouse. So there were 608 people who were traveling, and rest of the people were traveling in barge is a category which shows parent and child, and sibling is the one which shows sibling and spouse. Sib SP. Sib SP. This is the column where sibling and spouse are indicated. And we, there were people going. How many people were to each? So as I mentioned, Southampton. So 646 people, 73% Titanic were going to Southampton, and 158 people, total 19% of the total passengers going to this, and 77 people, 9% of the total passengers were going to Queenstown, presenting the same with. And here we are trying if data distribution is normal. So each is has a skew of 3. You know already that minus 5 to 0.5 is considered a normal. However, here has a very skewed 4.79, very high. Is the age, and by looking at this picture also we can say that it is normal. There is not a lot of variance in this. Going for the box players who we don't be considered outlier. We're looking at as age wise, and people with 55 considered outlier. We look at this as age column for understanding. Now here I have tried to draw range. So there were 14 people tried for less than 1 year of age. And out of 14, 10 people were able to then look at the age from a different angle here. There were 19 people who left the normal distribution purposely just to see what does the outlier according to the box plot says. What value does it have? To 70 years of age, 19 people were there and only 6 out of them could survive. 70 to 75 were 6 people and none of them over 75 years of age, which is actually 80 years. Is only one passenger there and that passenger. Then I'm looking at the box plot and the illness is 4.59 process. Kurtosis represents the yes, is towards one direction. This is zero point 0.4 because of the people traveling in passenger class 3. Because there were more number of people. 491 people were traveling, 55% of the total population on that were traveling. Okay, we are looking at the distribution of fare. So here also we can see very clearly the data is skewed. Most people have paid 100, less than 100, and very few people were there to pay 100. This is another, this is just another histogram for fare distribution. So how many people were there who got less than $100? There were 800 less than of two people than $100. 17 more than three. There was only one passenger with more than 500 that I have not included over here. But yeah, I saw that there was only one passenger. Next, this was the univariate. And now I am going to combine two columns and then multivariate analysis. In with I have done it. Survived in senior class call. Here we can see percentage traveling in passenger class one. 63% survived. 7 people did not survive traveling passenger. People who were traveling in class 2% not survive. 7 people did survive. The lowest people traveling in passenger class 3. Lowest chance of survival. Percent people only could lost. Same analysis is practical. Then looking at the wise gender wise, passengers had 74% chance. However, 26 of female could not survive. And in contrast, male passengers, 81% of the male passengers did not survive. 90 was competitive. Gender-wise, the difference is huge. Women who then we have this embarked actually is the location where people were going to have already. So people going to Southampton had lesser chances of survival. 34. This is uh, and the same here on the convention. Whereas two line then survive. And orange line here equal to, and with this, uh, in age, passengers with also were able to survive more. 30 of age is the class. Are the these are the people who were the young. Yeah, and they had more strength to help themselves as well, but it does not look like that they lost their lives. More number of people lost their lives than 55 to years of age. No number of people were able to survive for that. So that continue. People had Ashwin very less than at this point with 40, 5 to 40 had less and less chances of survival. These are all people having dollars, traveling better class, and survive. Actually, a fair plot it allows of on its own time to analyze lot of data is there. But I am not talking about it right now because I have been at the end of the code for clear because there are some feature engineering and after this another column was added. Families was the summation of thousand parent child column. Okay, this of the another column was that is based on this function. If the person was traveling alone, the family size would be marked as alone. People traveling size written 0, which is 1, 2, 4, be marked as medium family. And traveling the more than 4 member of family marked as light large family. Then we have this. Now we have imputed these in one column and we don't this reason that has been summarized in this one column. So we are dropped. Then the analysis is on the family type and see people travel alone lesser number of lesser chance to survive. This could be because they were in jail, they were drunk. They, basically, they may not have had help with larger number of families had even lesser chances of survival because they they, they get caught in helping each other and people traveling same size family want to had more chances of 56 44% of their lives in is visual representation here. This is actually showing the numbers. We're detecting outliers. So we actually have uh, is in fair columns where we need the outlier. Passenger ID, and passenger class. These are not really having any, and there is no, these are not numerical. It was wise to on the, because the already showed is almost normal distribution. Let's follow the Gaussian distribution. Uh, should be done with this standard, removing out the A. So here I have used three standard deviation technique where anything which is far than the standard deviation positive and negative outlier. On the theory that in normal distribution, 99.7% of the data is between plus and minus 3 standard deviation, right? That filtered this, we are left with 184 observations by calculating by the age, which are between uh, positive and negative standard deviation for outlier and column. And this is done with the QR. So the IQ is um, third quantile minus first quantile. Calculated the quantiles first, then Q3 minus is I. Then what we have done is outliers are considered further than the negative side 1 minus 1.5 times of IQ. The IQ 1.5 times here the IQR, and on the positive side plus 1.5 times of whatever is beyond these points. Have removed those after that we are left with 770 of the then one hot and this is the last thing left to do. Benefit of this is that when we are doing when we are applying the machine learning on this, when we are going to predict this data, uh, machine learning doesn't understand categorical data. It has to be numerical format. And you would also notice is passenger class 2 and passenger class. This is because when this data is feed machine algorithms, if there is uh, one, so one and two, the algorithm will get biased towards the number because it thinks two has more value. That when you have three columns, you should have only two columns to represent. So here we can see class 3, passenger class 3, and wherever passenger was traveling in passenger and that's the when both of the observation that means passenger was traveling goes with X, then may wherever the passenger was male one, or if it was a female, then it embarked same passenger class applies to embark also. For family size, family type, we in medium wherever apply it will column. If both are not, both are zero, then we was alone. That person was traveling alone, not traveling. Then we go. So here we can see here has a strong correlation. 7 on this is the lesser, the lighter the color is, the greater the correlation. Darker the color is, lesser the correlation. So notice the darkest colors have negative numbers, representing negative or none correlation. Wherever the number stronger the correlation. So fear had a correlation, very strong one because of the obvious reason they were doing good, not a lot of friends also in second class and first class. And class 1 and class 2 did not have a lot. So close to equal amount of people were traveling. See this type of this says that people who are traveling class of more chance to already and survival also has very this as well. People traveling medium-sized family had more chances of survival than who were traveling in large family or who were alone. Here the sex-wise you can see there is not a very good correlation. You can see it clearly shows that is here. So for female it will be a positive one. Survival had no correlation and plus 3 there is not a lot of correlation survival for, for passenger class 3 survival has minus negative 0.2 that people in this class have suffered more. Passenger class 2 has suffered, you can say a little, don't know how to verbalize that. Of presenting this data, they did not, there were two casualties traveling in passenger class. Looking at this data, this only this map can tell us so many things. Continue in the You can also see complete analysis in I have given a link in a complete. I have attached this for that's all from my side. Thank you.